Okay, in this problem, we're asked to calculate the current flowing through the 3 ohm resistor shown in the network below. We have several resistors here, and we see if we can combine them in series and in parallel. And one of the first things that we notice is we can combine the 6 ohm and 3 ohm in parallel. So let's go ahead and do that. We can create an equivalent circuit as an EMF source, a 10 ohm resistor, so 10 volts. We still have the 12 ohm down below, but now we're going to combine the 6 and the 3 ohm into one effective resistor. In order to figure out the value of that, we use the relationship for parallel resistors, which says that the reciprocals add, and that's equal to the reciprocal of the net resistance. This implies that the effective resistance of the 6 ohm and 3 ohm in parallel is 2 ohms. Now we have 3 resistors that are in series. We can turn them into a single effective resistor. We do that simply by summing the various resistances. So 10 plus 2 plus 12 is 24. Once we've done this, we can calculate the amount of current that's flowing out of the 10 volt supply. It says that the total current is going to be equal to 10 volts over 24 ohms by Ohm's law, and an ohm is a volt per amp. So it says that the total current is flowing 0.417 amps. Now we're not asked for the total current that's flowing out of the EMF source, we're actually asked for the current that's flowing through the 3 ohm resistor. So what we have to do is we have to use the result for the total current to calculate the voltage drop across the 3 ohm resistor. We do this by unpacking the circuit. We combine several things in parallel and in series, and now we need to go backwards using the information that we learned from that combination. So once again, this was 10, this was 12. This is a parallel series of resistors, parallel combination of resistors that was equal to 2 ohms. We know that the current that's flowing through here is 0.417 amps. What that means is that the voltage drop across the 2 ohm resistor, well, that's just equal to IR, so it's equal to 0.417 amps times the resistance 2 ohms, which is a volt per amp. When I multiply this out, this becomes 0.834 volts. Once I have this value for the voltage difference across the 2 ohm resistor, I know that since the 2 ohm resistor is equivalent to the following, a 6 ohm and a 3 ohm in parallel, I now know that the voltage across the 3 ohm resistor is 0.834 volts. What I can now do is I can take this voltage and calculate the current. The current is going to be equal to the voltage over the resistance. It's the voltage over this particular resistor divided by the resistance itself. I can compute this total, and I get 0.278 amps. And that's the answer.